Hello everyone, welcome to Twitter sentiment analysis tutorial. In this we are going to build a model for Twitter sentiment analysis. Along with that we are also going to build here a Streamlit application. So in Streamlit application, as you are seeing here, that you will be seeing a text input here. So with the help of this text input we will be reading our Twitter data, and at the back end there is machine learning model which is running. I'll tell you, I'll be writing those codes line by line. I'll be showing you how you can write that model to do the prediction. So I just click on the prediction, it does there the prediction. I just change the input. I click on the predict and then it does the prediction as the positive. It took these many of seconds. I change here again this input. I click on the predict. It here predicts as the negative sentiment. So this is a Streamlit application. We will be building this Streamlit application throughout this tutorial. We will start with the sentiment analysis. Then we will be discussing what is the random forest classifier. We will be also getting to know that pros and cons of the random forest classifier. Thereafter we will do the dataset analysis, and thereafter we will be doing some pre-processing and some data visualization. After these data visualization and the pre-processing, we will be doing here the stop words. We will be doing here the word cloud visualization. Thereafter we will be doing the data cleaning, and in the final part we will be doing the model building and testing. Once model building and the testing is done, the model will be stored, and then this model will be used with the VS Code Studio and app.py, and then these codes I'll be showing you how you can write these code just to see these results at the front end. So this is the application here, and here is the code for that application. Alright, so without the wasting time, let's go ahead and get started with this tutorial. Hi everyone, let's go ahead and get started with Twitter sentiment analysis with random forest. So in this lecture we will be using Twitter data for our sentiment analysis, and we will be also using here random forest algorithm for the classification task. So you need to understand first what is sentiment analysis. So the sentiment analysis is the process of computationally determining whether a piece of writing or a sentence is positive, negative, or a neutral. It is also known as opinion mining, or you can say that based on this Twitter you can know that what is the opinion of the person, whether it's the positive, negative, neutral, or you can say that if it is irrelevant based on the given data. So the positive sentiment is something where the person is trying to say something good, like a great service for an affordable price. We will definitely be booking again. So this is the positive review. Here it's a neutral, just book 2 nights at this hotel. So it's a neutral review. The person is neither talking about the positive or anything about negative. The negative review is horrible services. The room was dirty and unpleasant, not worth the money. So this is the negative review. The fourth type of review, which you can say that the irrelevant, which cannot be relevant to these 3 classes. Like let's say if someone has commented or tweeted something like this, that, or some random word which is irrelevant, which doesn't say anything either neutral, negative, or positive. Alright, so we'll be also using here a random forest classifier for the classification task. This random forest classifier is actually made up of decision trees. So there are a forest of decision trees. That means there are hundreds of the decision tree. That is why it is known as a forest of decision trees. And these decision trees are randomly assembled together. So the data is divided into multiple samples randomly. And then these data, which was divided randomly into the multiple samples, then these data were assigned to these multiple trees there. And then these trees do the prediction. So let's say randomly your random forest algorithm made here a 4 random trees here. So these are the decision tree here. So 4 random decision tree were chosen just for example, and each of these decision tree gave a class, let's say class C, class D, class B, and the class C. So thereafter the result of all of these these decision trees will be collected together. That's why it is known as ensemble. So the result of these decision trees will be assembled together, and then based on the majority voting the final class will be decided. And with this example you can know that, or you can say that the class C is here a major class, so the output of this whole data set will be class C, although these individual decision trees are giving class D and the class B as well, but based on the majority you will see that the final output of random forest classifier will be class C. So we'll be using scikit-learn library to implement random forest classifier. You can simply just click on this. So you can import random forest classifier from sklearn.ensemble import random forest classifier. So these are the input parameter which random forest classifier takes, like we saw here. So you see there, these says that the number of the decision trees, so that you can control with the number of the estimators. So this says that the number of trees in the forest, so how many trees you want, so how many random samples will be there. And thereafter the depth of these decision tree you can also control, the number of leaves here you can also control. So all these parameters are given here in random forest classifier at scikit-learn. You can use these parameters to control your algorithm implementation. Another important feature here, the number of job. So the number of job says that how many CPU core you want to use while training your random forest algorithm. Alright. So what are the benefits and disadvantages of random forest algorithm? So there are many benefits of random forest classifier. Like random forest classifier is accurate classifier. If you compare this random forest with other classical algorithms like support vector machine or logistic regression or any other classifier, so you will see that it is quite accurate, and given that it is fast as well. It is robust to outlier and nonlinear data, and it do not overfit. So the random forest also does not overfit. Original paper of random forest suggests that because of the random split of the data and the ensemble property, random forest algorithm does not overfit. And it is highly scalable to any data set size. If you have a large data set, obviously it will take a lot of the time, but still it can handle a large data set. It's not like the support vector machine. For a support vector machine, if you give a very large data set, then your support vector machine starts taking a lot of time because it needs to make there a lot of planes there are support vectors. Random forest algorithm can handle missing values efficiently. It is very good. And if data scales are not same, then random forest algorithm also can handle those. But other algorithms need to have same scale data. For example, if you have two columns, let's say the salary and age, and the salary goes in the numbers numerical like millions, but age are mostly less than 100. And if you see the scales, the difference of these scales where age have hundreds there, just 2 zeros is there, but the salary have there 5 or 6 zeros are there, or more than 6 zeros could be. So there is a huge scale difference. And if you use that data in generic classifier, then those will be tilted toward the salary part because the scales are very much high there. But that doesn't happen in case of random forest classifier. So it handles those very well. Other than that, the random forest algorithm can be used for the feature selection. Now the feature selection, I have made here a YouTube playlist for the feature selection. You can visit to this playlist. For this given link, you can watch all these videos for the feature selection. So in this feature selection series, I have shown that how you can use different type of the features, how you can use the different type of feature selection techniques to improve your algorithms. Like here you see the random forest, how you can use the algorithm accuracy by using feature selection technique. But there are some problem with random forest classifiers, like it can be computationally expensive if you have a lot of trees. For example, if we use this random forest classifier and if we increase the number of estimators, then it is going to take a lot of time. So these could be a problem. Other than that, there is another problem with the random forest algorithm is the space. So if you compare the size, the model size of support vector machine and random forest algorithm, so you will see there the size of random forest algorithm will be a huge as compared to the size of the support vector machine here. All right, but when you do the final prediction, although the size of random forest algorithm is huge, there are larger than the support vector machine or SVM models. But if you compare the inference time, that's when the time to predict the data, I mean the time to do the prediction, you will see that the random forest algorithm is faster than the support vector machine. So we will be using here a Twitter sentiment data. The data set is given at my GitHub repository. So you will see there all CSV ML data files download. You need to visit at Lakshmi Merit. So there I have a Twitter sentiment. Then you need to click here on the raw. So as you click on this raw, it will open here raw format of this Twitter sentiment data. Then you just need to copy this. You just need to copy here a link so that we can read this data directly into the pandas data frame. Other than that, to pre-process this Twitter sentiment data, I'll be using here a preprocess KGP Talkie package. So this package is also available at my GitHub repository here, Lakshmi Merit preprocess KGP Talkie. And in this preprocess KGP Talkie package, these are some of the dependencies which you also need to install before going through the NLP tutorial, NLP project 3. Alright, so these things we need to install. In coming time, we will be installing all those, the packages. So basically you can copy these from there and then you can paste it here and you can install here. Alright, you need to put here exclamation mark and then pip install spaCy, pip python spaCy download web download English language model, a small model, beautiful soup 4 to remove the HTML tags from the data. And then we also need to install here the text blob to work with the preprocess KGP Talkie package. So I have already installed, so I'm not gonna install these again. So I'm just gonna comment these. But if you are watching this the first time, this NLP project 3, then you need to install these packages. Otherwise, preprocess KGP Talkie will not work. Just to watch the other NLP projects, you need to come to my channel here at the KGP Talkie. So you can here write simply KGP Talkie, youtube.com/KGP Talkie, then come to here a playlist. So in this playlist, you will see there the NLP projects, NLP tutorial. So in this NLP projects, I have already uploaded the 2 projects. So these 2 projects are there, NLP project 2 and NLP project 1, where you can build spam message classification and then you can build their IMDb sentiment classification. So these are the two lectures already available with NLP projects. This is the 3rd lecture. Alright, so here is the process to get started with our NLP project. First of all, we are going to load the data set. Thereafter, we will do the feature extraction. Then we will be doing the data visualization. Thereafter we will be doing here the data cleaning, and then finally we will be doing here the train test split, and then the model building, model training, model evaluation, and then the model saving, and then finally we will be building Streamlit application. Alright, now let's go ahead and import the necessary packages to get started with our coding. So the first of all, I'm gonna import warnings so that I can suppress some warnings. So then I write here warnings. Just to auto-complete these commands, you can simply press the tab button on your keyboard to auto-complete. So I press here the filter and then the tab. I get here the filter warnings. I'm gonna filter all the ignore warning just to make sure that our code looks good. Thereafter I write here import pandas as PD. Alright. Perfect. So once you have imported all the necessary packages here, in fact there is only one necessary package we imported here, pandas as PD. Now we need to read this data directly from here. So I write here the df, which is the data frame pd.read underscore csv, and you put a cursor inside these parentheses, press shift and the double tab. You will see all these parameters which these read CSV takes. Like you need to provide here the file path, the separator, that's mean the file paths, these file data separator. So it's the CSV, that's mean the by default separator is comma there. And thereafter, if you want to provide any kind of the delimiter, special delimiters, or headers, name, and so many other parameters it takes, although we don't need to give all these parameters in one go. So basically I just need to give here the path. That's all I need to give. And if you read your data, you will be seeing there the data will be directly downloaded from there. Let's go ahead and visualize here the first few lines. So df.head will show here the first 5 rows, and first 5 rows have here a positive review. And seems like the first review itself is going as a header. So I write here header equal to none. Other than that, one more thing you see there, the index here. Alright, so the index says that here we have got this index coming here along with the data frame. So there I say here index is equal to none. Once I do all these things, in fact it's not the index that you can figure out from here. You just press here shift and tab. Let me just do it here. You just press here the shift and tab. You will be seeing here all the details. So it's the index call, actually the name is here index call, and this index call I'm gonna give here the 0. So the 0 will make sure that the first index, the first column actually goes as the index here. Now these 3 columns we have here. So these 2 and 3, these 2 columns are only important here. Now what I do here, I just export these 2 columns. For that I write here df 2 to 3. So only these 2 columns, this and this, these will be exported here. Thereafter I do here the reset underscore index, and then I say here drop equal to true. So what this drop equal to true is going to do, when we reset the index, then these index will be starting from the zeroth value. That's mean the 0 value, 0, 1, 2, 3, something like that, it will be there. And I just run it. Seems like something is wrong here. Let me just see it here. In fact, it should be something like this. And now if you check your data frame, we are having here 2 and 3, and our index is also here. The reset of these index has also happened here. Alright, so we have the data frame df. Let's go ahead and assign some columns to this data frame. I write here df.columns, and the first column is here the sentiment, and the second one I'm going to provide here the column text column. Once all these things are done, then I'm just gonna visualize here first 3 rows of the data frame. So it has the sentiment and here is text data. So as I told you earlier that these are the steps which we are going to follow. So this step says that the load the data set. Thereafter we are going to do some basic analysis and then we will move to the feature extraction. So some basic analysis, whenever you load your data in the data frame, it is always recommended to do some basic analysis. So some basic analysis are something like this, like you need to check df.info. So with the df.info, you will get the information that what are the columns and the data types. So these two columns have a data type as the object, which is obviously here visible. But in case if you have data frame which have, let's say, 10 or 20 columns, then you need to know the data types of all of these columns. Then df.info is really very helpful. Other than that, df.info also says that how much memory your data frame is taking. So currently this data frame is taking 1.2 megabyte of memory only. Other than that, you can check if there are any null values, so that you can check with df.isNull.sum. So with this you will see here there is almost 686 null values with the text data. So here we need to do some pre-processing with the text data, because in the text data what we see here, let me just show you some samples, some random samples. df.sample. So this is going to give us some random samples. Now you see there it has the length just like less than 10 character. Similarly we will be having so many tweets which are having less than 2 characters, or you can see that just 1 character. So what we need to do here, we need to filter out all those the tweets which have less number of characters there. All right, so basically first of all we need to drop here all the null values. So I write here df.drop na, and then I write here in place is equal to the true. Thereafter I write here the df equal to the df and then df text. All right, so in the text, now you see what I'm going to do here. In fact, I'm going to calculate the length of this text data. All right, so I'll be calculating the length. Thereafter, I'll be filtering out all the text data which have length more than 5. So I write here df.text. Thereafter, I'm going to use here apply method. And in this, I'm going to directly use here length method. So if you do like this, this is going to give you the result something like this. All right. Just a second, let me just see it. So some error is coming. Okay, so the reason is here, this is coming because of these null values. So basically I just need to run this once and then you just run it. So this is going this is giving you the length of the tweets. And in this, if you check here, the value counts. So you will see there are many which have the length less than 1. I mean less than 2 or 1, you can say. So basically I'm just gonna check here. If it is greater than 5, then it's going to true, otherwise it's going to false. And then if you sum it here from here, you will see it here. So there are 72,000. All right. So there are 72,000 when it is greater than 5. And how many tweets have less than or equal to 5 that you can identify? So there are 2,113 tweets are there which have characters less than 6, 5 or less than 5, you can say. All right. So based on this, we now know that we have to filter out 2,113 tweet data. So for that, I'm just going to copy this from there and paste it here. So df text apply length greater than 5. So it's going to give you either true or false. Whenever the true value, then that index or that row will get selected automatically, and for that false value, that will get automatically, the discarded. So for that, you can check here shape of your data frame. So basically you can do here the print df.shape, and here again you can do here the print df.shape. So this shape is before this pre-processing and this shape is after the pre-processing. So here it says that the first we had almost 75,000 rows, but after the pre-processing we are having here around 73,000 rows. So that's the difference here, almost 2100 rows just got subtracted from here. So now we have our data frame. Now if you do here these random samples, you will always see any tweet data which will be having at least 6 characters. Alright, thereafter let's go ahead and check the sentiments. So the sentiment now we have. Now let's go ahead and check the sentiment, the value counts. So what type of the sentiments we have with our data. So you can do that with df sentiment dot value counts. So in this we see here that negative have almost 22,000, 20,000 positive, 17,000 neutral, and 12,000 tweet is there which is irrelevant. Although this data seems like a little imbalanced, but it's not a very high imbalanced data. So we can manage with this data without any kind of the balancing. So we can use this data as it is. Now we have reached to pre-processing with preprocess KGP Talkie package. In this step, we will be using preprocess KGP Talkie package, and this package I have already shown you. You can find it at my GitHub repository, github.com/Lakshmi Merit preprocess KGP Talkie. And in this preprocess KGP Talkie, you need to click here at preprocess KGP Talkie. Thereafter, you will see here list of files which is used inside this preprocess KGP Talkie. Then you can click on here init.py. So here are the methods which you can use. So these are the methods which you can use to get the basic features of text data. In the last, I have shown here a method which says that get a basic feature. So using this, you can get a basic feature from our Twitter data. Now we need to import preprocess KGP Talkie. So it's very much simple. You just need to do here import preprocess underscore KGP Talkie as PS. Thereafter, you can simply pass here data frame df. Basically, what you can do, you just check the head of the data frame here, or you can just check the columns of the data frame here. In fact, whatever you choose. So currently we are having here just 2 columns. So right now what we can do here, df dot columns. With this, we have here the 2 columns. Now I say here df is equal to ps dot get basic features, and this get basic feature takes the data frame df, and whatever the data frame you pass here in get basic features, you need to have a text column there. So by default it takes here a text column. So as soon as you run this, it's going to calculate some basic features. So what are the basic features? In basic features, you will be seeing there the character count, word count, average word length, stop word count, hashtag count, all these things you will be getting. Let's go ahead and check the columns of the data frame. Now we have got these additional columns. So there are 8 additional features got calculated after we called get basic features. In this we have got character counts. So this the character count, if you check again the data frame dot head. So in this, the character count of the text column is calculated here, the number of words, and these words are broken here on a space. So the number of words comes into this, the average word length, that is the number of word count divided by the character count. Thereafter you have here the stop word count. So stop words are the basic words which are mostly used. So you can say the stop words like on, I, will, you, all, and all these are stop words. So stop words are most frequently used English word, and which do not have any kind of the specific meaning, but although these words are used to connect two words together, so these are mostly like the preposition, or sometimes sometimes verb is also kind of a stop words, like is, are, am, all these are stop words. Thereafter we have here the hashtag count. So the Twitter, in the Twitter data, sometimes we have the hashtag, sometimes the people do something like this on the tweet data, so the hashtag count is also calculated. Thereafter the mention count is calculated. So the mention count starts with like this, and thereafter the digit count, so whatever the numbers are there, numerical number counts are there, and then if anything mentioned in the uppercase, so those counts are also here. And if you count, there are 8 features. Now what we can do, we can plot these 8 features together just to see that how these 8 features are distributed for each type of the sentiment. How many type of sentiments we have here? If you remember, previously we checked there are 4 type of sentiment. Basically we have a positive, negative, neutral, and irrelevant. So we can check these distributions on these type of sentiments. Let's go ahead and do the visualization of these features. So for visualization task, what we can do here, we can import matplotlib.pyplot as plt, thereafter import seaborn as SNS. So basically we can use matplotlib or seaborn to plot it, and you will be having option here. Either you can use the matplotlib directly or use the seaborn. Well, so we will be using here seaborn, and matplotlib plt we will be using to set the grid type and some figure aesthetics. So as I told you that there are 8 features, and these 8 features now we want to visualize into 2 rows and 4 columns. That means 2 rows into 4 columns, there is 8 features, alright, and then there would be 8 plots there, and these plot we want to do with plt.figure. Alright, so I write here the plt.figure, and in this I write here the fig size. So the fig size I'm going to use here the 20 cross 10 figure size. So it's like it has 20 units in length and 10 units in the height. Thereafter we have here the number of columns. So I write here the num calls equal to df.select. So basically we want to plot these numerical columns. So how many numerical columns are there? There are 8 numerical columns. Either you can select these numerical column manually, or you can write a code here. So like you type here df.select dtype, and then you write here include. So what numerical data type you want? What type of the data you want? So I want data type equal to number, and then I select the columns of that data frame. So if you select particularly this one, you will be seeing here only numerical columns. Now I type here dot column, so I'll be getting here the number of the columns for the numerical features. Thereafter I iterate over these number of columns, or you can just print here this number of columns just to verify that you get all the numerical column. So these are the 8 numerical column. I iterate over these numerical columns. So I write here for call in number of calls. So these are the 8 columns. I write here the plt dot subplot, and as I told you, we will be using here 2 rows and 4 column, and in this subplot I want here the number of columns. You see there, this is the index type. So this index type, you can get here the number of columns dot get location and then the column number. All right, so something like that you can do. Otherwise, what you can do, you can iterate over here something like this. So index call enumerate and then the number of columns. All right, so this index, we will be, with this index we will be getting, you know, the numbers there. So I write here index plus 1. So if you run this, you will be seeing here 8 plots, 1 2 3 4 5 6 7 8. In these 8 plot, now we want to plot these columns here, starting from here. So to plot these, I'm going to use here a seaborn KDE plot. So I write here sns.kde plot. This is the kernel density estimation plot. So sns.kde plot, and this plot takes the data as df, and if you run, if you press shift and the double tab, you will be able to see here the details there. So we pass here xy. Otherwise, you can pass their data directly, and thereafter you can pass you can pass the number of columns against the x-axis. So I pass here x equal to the column. All right, so this column is selected from these number of columns. It will start with the first, which is the character count. Thereafter, I'm just gonna, simply run here the plt dot tight layout, and thereafter the plt dot show. Let's go ahead and run this. So as soon as you run this, you will be able to see here that a plot is made here. The character count, word count, average word length. Thereafter here you have here the stop words, hashtag count, mention count, and then digit count, upper count. So all these counts you are able to see it here. But as we mentioned earlier that we want to see these features against each type of sentiments. So for that purpose, you can pass here the hue. So hue will change the color of these plot based on the sentiment. So I need to pass here sentiment column name. So the column name is a sentiment here. Thereafter I just run this. So now you will be able to see there a 4 plot for each of these type of sentiments there. Alright, so out of these 4 plot, now what you can do, you can use there the fill as well, just to fill these empty plots as well. So I can just write here the fill equal to the true. And if you run this, you will be able to see a very good and nice aesthetics for your plot here. Maybe these numbers might be looking low to you. For that purpose, you can reduce these. I'm going to reduce here the 12, and then this I'm going to make it here the 6. I hope that now I would be getting here a larger figure. So now I get here a larger figure, and in this figure now you can see there you have sentiment positive, neutral, negative, and irrelevant. So if we try to understand these, I can see it clearly. Seems like with this fill it is not very much clear. So I make it here false so that I can see it clearly. Alright, so with this we see here there is the irrelevant. So with this irrelevant, now you can see the character count is very less if if sentiment is irrelevant. So basically it is those type of tweets which do not have much of the context, or the overall character counts are less, then these are irrelevant there. So this density says that what are the maximum number. Alright, other than that you will be seeing here negative, positive. So negative and the positive one seems like they are having equal type of the density in case of the character count, and then this neutral one are having there the mid level of the density. Similarly, if you see there the word count, so the word count seems like if you zoom it a little, you will be seeing there the negative one have a little bit more word count as compared to the positive or any other type of the sentiment, because you see it's coming here this side. So if it is coming this side, that means it has more number of words in a tweet. And it is very much obvious that, because whenever people write negative feedback, then they try to include their many information. They try to convince the brand that why they did not like their services or product. Other than that, you will be seeing here that sentiment here, the positive sentiment here, the density is again high in case of the stop words. Other than that, in the negative sentiment, you will be seeing here that it has here negative sentiments, and it has again a more number of stop words as compared to other type of the sentiments. Similar behavior probably is not seen in any other the features, like in hashtag count. It's extremely it's extremely low, so it's not visible here, it's not clear here. Other than that, you have there the mention counts. So in case of the mention counts, we have here the positive sentiment. Again, the density is quite high in case of the positive sentiment, and moreover all other sentiments seems like overlapped here, so it's not very much clear. But here it is clear that we have a positive and negative one, density is quite high, the digit numbers, but in case of the irrelevant and neutral, these densities are less. And similarly, you will see here in the case of the uppercase count, these are now let's go ahead and do the pie plot just to see that how our sentiment these four type of sentiments are distributed. So we'll be using here the same concept like we had used here the earlier. Sentiment dot value counts. In this you will be having here a four type of the sentiments, and in this you just need to write here the plot and the kind of the plot which we are going to use here, the pie plot, and then auto PCT. So this auto PCT is going to give us the distribution in percent. Alright, so here I write here the percent, alright, and then 1.0 f, that's the float point, and thereafter I need to write here the double percent. So this one and this one is used for auto PCT, and this one says that it will use 0 or no digit for the decimal representation. It will present only integer presentation. Thereafter I just run this, you will be able to see it here. So it has 30% negative, 28% positive, 18% irrelevant, and 25% neutral. So with this you will be seeing there the density for the negative sentiment is quite high. So the similar behavior you can see it here as well, like for negative sentiments and the positive one, negative here and here the positive, 28 and the 30%. That is why these peaks are quite high in case of positive and negative sentiments. Irrelevant percentage are quite less, that's the share of irrelevant tweets are less. That's why we see here the density for irrelevant tweets are quite less as compared to other sentiments. Let's go ahead and do the final piece of data visualization. Now we are going to see a stop word. In fact, now we are going to see there the word cloud, not the stop word. So you can see that here like word cloud visualization. So what is the word cloud? You can just simply copy this whole thing from here, and just for your understanding I'm just searching it on Google. So word cloud is something like this, where we will be plotting these individual words, the most significant individual words, these will be plotted. So with this you can get the gist that what type of words are used here mostly. So for this word cloud, you need to have their word cloud library. So you need to install word cloud, and it's very simple. You just need to write it here, pip install word cloud. Alright, so you just need to run it. I have already installed, so I'm not installing this. Once installation is done, then from word cloud import word cloud and stop words. Alright, thereafter I write here stop words equal to set of stop words. Now you can check these stop words here. As I told you earlier, these stop words are most frequently used words in English literature, and we will be using these stop words just to remove the stop words for plotting. Like you see these plots, you will not see any stop words, because if you don't remove the stop words, you will be seeing here the mostly stop words. So we don't need these stop words. Okay, so to remove these stop words, either we can remove from the text data directly, or we can use this word cloud library itself not to plot stop words. Okay, so what you can do now, you can simply write here word cloud equal to word cloud, and in this we need to pass here our data. All right, but before that, in this word cloud you put here shift and tab, you will be seeing here all these details. So with these details you can set the aesthetics of your word cloud. So currently I'm just gonna pass here few things like background color. I want here white background color. Thereafter stop words, I set here the stop words, that means do not plot stop words. Other than that, I set here the max words. I set here the maximum number of words to plot in the word cloud is 300. Thereafter I set here the max font size. So I use there the max font size as 40. Thereafter I scale our image by 5 just to increase its resolution. Once you got this word cloud, thereafter you can just click there on this word cloud as generate. Alright, so thereafter this generate, you will be passing your data. So I write here generate, and you put there parenthesis, shift and double tab, you will be seeing the data. Okay, so data is not coming, no problem. So you know your data is stored in the data frame df, and then it is inside the text data. You just simply need to do this, it will automatically plot here. Okay, seems like something is wrong, just let me see it. Okay, seems like we need to pass here string data, so I set here str. Okay, so there I have word cloud. Now I say here plt dot imso, that's the image show, and then inside this I pass this word cloud. Now you can see it here that our word cloud is plotted. So in this word cloud, what I see there, I have the highest, the words are like the getting, murder, Johnson, coming, kill, will, length, all these we are seeing here. Alright, now what we need to do, we need to plot these word cloud for all the columns. So currently we are seeing these word cloud for all the data set, including all the columns which we had seen earlier, I mean all sentiment. Now we need to plot this word cloud for these individual sentiments. So there are 4 types of sentiments here: positive, negative, irrelevant and neutral. So we need to plot here 2 by 2 plot there. So to plot that, I need to write here plt dot figure. So it's like the same thing like we plotted earlier for our numerical data analysis. And in this figure, I want to set here 40 cross 20 units for the image. Thereafter, I write here for index and then the number of the columns which I'm going to use here. So I'm gonna take, the unique values for the sentiment. So instead of this column, I say here sentiments. Enumerate the data frame sentiment dot unique. So there are 4 types of the sentiments. Those will be calculated with df sentiment dot unique. Thereafter I write here the plt dot subplot and then 2 cross 2 and then I'm gonna just do here the index plus 1. So this index plus 1 will be referring there the first plot, second, third, fourth, fifth and like that. So the index starts with the 0. So 0 plus 1 is 1. So the first plot. If you just run this, you will be seeing here the 2 by 2 plot there. After this 2 by 2 plot, I set here the df1 equal to the df sentiment equal to sent. So this sentiment you will see there are 4 types of sentiments. For each type, this value will get filtered and this will be placed here in df1. Thereafter in this df1, in fact I can get the text data directly from here and I can write this data directly instead making multiple data frame. Thereafter the similar code we need to write there. So I just copy this whole thing from there and then I paste that here. So these will be exactly same, and here only I need to change this because this df text I have already taken in the data, so I just need to do that. Thereafter you just need to write here the plt dot imso and in that you need to pass here the word cloud. Just run this, you should be able to see here the 2 by 2 matrix, and in these 2 by 2 matrix now I am able to see it here, but it is not clear that for which particular sentiment these plots are there. Now we need to do here some extra pre-processing. So for those pre-processing I write here the plt dot xticks, and here I'm gonna set these xticks as a null value. So these numbers or those pixels which you are seeing there, those will be hidden. And similarly I write here the plt dot yticks, and here I set here the empty yticks. Thereafter I write here the plt dot title, and in this I need to write there the sentiments. Alright, so now it will be giving here the sentiment which we are going to use, and then the font size I need to use here. I set here the font size equal to 40. Let's go ahead and run this. As I run this, you will be seeing there a title for each of these subplots. So now I can see there is a positive review for this. The word cloud is here, and for neutral we have word cloud is here, and for negative we have word cloud is here. So like the people might say that the biggest disappointment, Chronos, acronym watch, didn't, disappointment. So these seems like a negative sentiment. And irrelevant are something like this, where the people are talking something irrelevant. Concept, Microsoft practices, text, appreciate, actually, bring, party, sound. So with this word cloud, this really looks good, and you can use this for your purpose if you want to use it for somewhere else. Alright, so all the data visualization part is done now. Now we need to move to the data cleaning part. Let me just again remind you the process which we are following here. So the data load, feature extraction, data visualization. Till now we are done. Now we need to move to the data cleaning and train test split. So now it's very simple. We will be again using preprocess KGP Talkie package. Here we have some pre-process, some techniques which we will be doing here. Like you need to search here the remove parts. So you will be doing there remove URLs, remove retweets, remove special characters, remove HTML tags, remove accented characters, remove stop words. All these things you can do, remove rare words and remove common words. So anything starts with the remove, then those are used for the data cleaning. So here I write here the data cleaning. Alright, so for the data cleaning part, it's very much simple. I write here the df text is equal to df text. Alright. Here I need to use dot apply, and in this dot apply I write here the lambda function. So you just write here the lambda x and then x dot lower. So this is text data normalization, where we make all the text data as lowercase. Thereafter I'm gonna use here df text is equal to the df text again dot apply, and then here the lambda x, and here I write here the ps dot remove URLs. Alright, so in the remove URLs, I'm going to remove all the URLs if there are any from the text data. Similarly, I copy this and paste it here 3 and 4 times. And now the next time I'm going to do here the remove, and you press the tab, you will be seeing here all the available options to remove. Now I'm going to remove here the HTML tags. So I write here after URLs, and thereafter again you type here remove and press tab. You will be seeing all these options. I'm gonna remove here special characters. In fact, before special characters, I'm gonna remove here RT, which is remove retweets. Thereafter I write here remove special characters. If you want, you can also remove other the other features as well, but for time being I'm just going to remove these 4 here: URLs, HTML tags, retweets and special characters. Thereafter we come here, and then we are going to do here the train test split. Here I write here the from sklearn dot model selection import train test split. Thereafter I write here x train and then x test, y train, and then I write here y test equal to train test split, and here I'm gonna write here the df text. So you know this train test split is going to be used here to split our data set into training and test set. If you press here shift and double tap, you can see the details of this train test split. So for time being, I write here train test split df text, thereafter the df sentiment. So the df text, the first one is the x and the second one here is y. Thereafter I write here the test size. So in the test size I write here the 0.2. That means the 20% of data will be used for the testing. And then I set here the random state equal to 0, so that I can get the same set of the result every time I run this. I just run this. Now I can check the shape of train and test sample. So I check it here, x test shape and train shape. So the train data have total 58,000 rows and test data have almost 14.5 thousand rows. Okay, so the train test split is done. If you remember our steps to complete this tutorial, after train test split, the model building was necessary. So model building was to be done. Let's go ahead and do here the model building. I write here model building and testing together. All right. So I'm going to build the model. So for model building, I type here from sklearn.featureextraction.text import tf-idf vectorizer. Alright, so this tf-idf vectorizer, let me again show you on sklearn. So on this sklearn, I'm gonna search it here. You will be seeing this tf-idf vectorizer. So this tf-idf vectorizer is imported from the sklearn feature extraction.text. It takes a lot of the features here, and here some of the features are important, like what kind of the analyzer you want, whether you want to remove the stop words or not. So these features we will be testing with our tutorial, and we will be seeing whether using the various feature of tf-idf vectorizer will benefit us or not. Alright, thereafter I import here from sklearn.ensemble import random forest classifier. Thereafter from sklearn.pipeline import pipeline. Why we want pipeline? With the help of this pipeline, we are going to keep these together. So it's like the container which is going to combine tf-idf vectorizer and random forest classifier together. So I create here the CLF, or you can say a pipeline, and in this pipeline I put here a list of components which I'm going to put inside this pipeline. So there are the two components inside this pipeline. First, tf-idf vectorizer. So this tf-idf vectorizer goes first. Thereafter, I also give the name to this tf-idf vectorizer. And thereafter the second one goes. So for that I give here the random forest classifier, and here our random forest classifier goes. Now inside this you can give these individual features for these individual features for these the methods. Like for tf-idf vectorizer, you put their cursor and press shift and the tab. You should be able to see, otherwise you just copy and paste it here. You just need to run this and then press their shift and the tab. You will be seeing here the detailed documentation. So in this you can try these features, and for time being we will be using here stop words feature. Okay, and in random forest classifier, shift and the tab will again work here. And for this I'm going to use here the number of estimators. By default anyway it is 100, and the number of jobs is set here the -1 perhaps. Let me just see and confirm that. So this particular things I just need to set, and the rest of other things I'm just gonna keep as it is. So the number of job equal to -1 will make sure that all the available core are used for the training. Thereafter it's very much simple. I just write here the clf.fit, and then I write here xtrain, and then here I write here ytrain. Thereafter I just simply run this. You should be able to see your model is getting trained here. Once all these training is done, then we need to do here our model evaluation. We need to evaluate how much accuracy we have got. So from sklearn.metrics import accuracy score, or I can import here classification report. Alright, so in this classification report I need to write here the predictions equal to clf dot predict, and inside this predict I need to pass here our test data. Now the training is done there. We have imported classification report. Then I write here clf.predict, pass their x test data. So the training was done here and the prediction will be done here, or you can simply write here ypred. This is the predicted value. Thereafter you can print the classification report. In this classification report you press shift and double tab. Okay, so you need to first import this and then shift and double tab works there. You put it here, your cursor. So you get first y true value and y predicted. So this y true is y test value. So I put here y test and then y predicted value, which is the y pred value. Thereafter I just simply run this. You should be able to see there a 92% of accuracy is achieved here. This is very good accuracy on the given data set. By using a very simple method, getting a 92% accuracy is very good. Okay, let's go ahead and try out some other features. If you can if you can use those features, and let's see if these works here. So I write here stop words equal to stop words. So with this method, the dictionary for stop words will not be calculated. Alright, that means TF-IDF will not be calculated for the stop words. Thereafter we are going to see how much accuracy we are going to get here. So the training is done here, and I can see here accuracy seems like accuracy seems like same. I don't see any changes because these, the numbers you see exactly same, and all other numbers are same. So it doesn't matter for this particular problem if we remove stop words or not, and the output seems like have same accuracy here. Let's go ahead and move ahead and save this model so that we can build Streamlit application. So I write here import pickle, and then I write here the pickle dot dump, and then I'm just gonna save our CLF, that's the classifier. Open Twitter sentiment.pkl. I need to open it into binary mode. As soon as I run this, you should be able to see your Twitter sentiment pickle model just got stored here, and the size of the model is 340 megabyte. Because we are using here random forest model, that's why the model size is quite large here. Let's go ahead and do some testing. So for the testing, it is very much simple. You just need to hear the CLF and write here the predict, and inside this you just pass here your the text data, whatever you want to predict here. So I write here let me not upset you, and just do the prediction. So it says that negative something, some people seems like talking about some negative sentiment. All right, and I write here really glad to see you. Let's go ahead and run this. It says that it's the positive one. Let's go ahead and copy something, and I write here something like this. See here, it says that still it's a positive. I want to see that when it says that it is irrelevant. So for that purpose, if you check here for irrelevant, it has concept, appreciate, bring, party, sound, all these. Let's see if it works on these, like the concept it has. All right. Anyway, seems like it's not working for the irrelevant one. Probably we want a little bit more here for the irrelevant. Just to make sure that it works, we can type something like the type of the data like this irrelevant sentiment have, like the how the hell are we into Halloween month already, something like this. So here it says that it's irrelevant. Similarly we can do for the other type of the sentiments, like here we have the neutral one. So for the neutral one, here I have text data where the people are playing a Borderland game there. So I write here I have done nothing but play Borderland. Let's go ahead and run this. It says that negative because of this nothing, but if we just remove that, it says that they're the positive. Okay, anyway, Borderland. So it's a little difficult to get that other one. The reason is here we have very less number of very less number of the rows for the other sentiment type. But anyway, if you see the overall accuracy here, it's the 92%. So it says that out of 10 times there are chances that at one time you will be getting there the wrong prediction. All right, perfect. So now let's go ahead and try to build our Streamlit application. So with the application we will be building we will be doing the prediction of these on the front end. So it's very much simple for the Streamlit. I just need to go back on the in the same project directory where this project is stored, and at that place you can simply sorry, not this view one. I just need to go there at here the NLP project 3. Inside this NLP project 3 I need to open this into the VS Code Studio. So in this VS Code Studio, I just remove this and this. Okay, so in this VS Code Studio I need to write our function so that I can use here Streamlit. Other than that, I just need to zoom this VS Code Studio so that you can see it clearly. Okay, here I create a file named as app.py, and then in this file I need to, first of all, I need to create here the title, but before that I need to tell you that how you can install these Streamlit. But if you have been watching my previous videos, here as I have told, so there I have already told that how to install the Streamlit. Just for the simplicity, I'm just going to write this again. Install Streamlit using pip install Streamlit. Thereafter I'm going to tell how you can run the Streamlit. Just to run the Streamlit, you can see here Streamlit run app.py. Okay, so let's go ahead and import the Streamlit. So I write here import Streamlit as st. Thereafter import pickle. So we need this pickle just to load our model, and thereafter import time just to know that how much time it is taking for the prediction. Thereafter I write here the st.title, and in this I write here Twitter sentiment analysis. Let's go ahead and run this. So I open here a terminal. In this terminal I run here Streamlit run app.py. So as soon as I run this, you will be able to see here these URL. I'm just gonna copy this URL and then I paste that URL here. Okay, so in this URL now I'm able to see this front end, and this Twitter sentiment analysis is written there. Now as the next part here, I'm going to load the model. So after loading these model, we can do the prediction. So I load model equal to it's not the st, in fact I need to load it with the pickle dot load, and then I need to pass here the file path dot load open. In this I pass here Twitter underscore sentiment dot pkl. Thereafter read binary here. Alright, so what I see there, I'm gonna read our the model with the pickle, and it is stored here in the model. Thereafter I write here a tweet equal to st dot text input. So why this text input is needed here? The reason is we need to get our input data from the front end. So if you see your this application, you just click on always run. In this application now we need here Now we need here we need here a text input so that the user can write the message for the prediction. Okay, so seems like something is wrong here. Okay, the problem is here actually, not there. Okay, thereafter in the text input I write here enter your tweet here. Okay, so it's something like this. Let's go ahead and come back here. Now you are able to see here your input, text input is here. You can write whatever you want to write there. Thereafter we just need to create a predict button. So I write here the submit equal to st dot button, and here I write here the predict. Now you can see there the button should be visible there. This predict button is visible there. Now if button is clicked, that means if submit, then I take here the time so that I can understand that how much time it is taking for the prediction. Thereafter I write here the prediction equal to model dot predict, and then inside this I pass here the tweet which we have taken from the input data. Once all these things are done, thereafter I again store here the end time so that I get with the time dot time. Thereafter I write here the st dot write, and then here I write prediction time taken. How much time it is taken, I'm just gonna do here the round end time minus start time. So basically whatever the time is here minus this time will tell you that how much time it took to do the prediction. In this round value I want to normalize the decimal point by the 2 places. Thereafter I want to write here it took these many seconds. Thereafter I write here the print predictions. Alright, and this 0 we need because if you check our predicted value here, so it is inside a list. So to get this particular value we need that 0. Thereafter I write here the st dot write, and then I write here the prediction 0. Otherwise if you don't write, then you will be getting the output as the list there. So here I write here predicted sentiment each. It's like this. Let's go ahead and come here, and here I just write something. Let's go ahead and just copy these from here itself. I write here let me not upset you. I just copy and paste it here. It's going to run. It says that it took here 0.04 second, which is a 40 millisecond, and the predicted sentiment is here negative. And similarly if I take here the another one from here and the copy and paste it here, and then you will be seeing here the positive one. This was quite fast. Then here we take the second one, and with the help of this second one, if I put it here, you will be able to see it as the irrelevant. Alright, so the congratulations, you have built here your Streamlit application. And this Streamlit application is very helpful when you are trying to deploy your model in the production, and you want to give your model for the testing so that the other people also can test your model. Congratulations, thank you so much for watching this video. Please like this video, subscribe this channel, and share this video on social media and with your friends. Thanks a lot.